Okay, if we need help with balancing, we have to make sure we know our terminology, okay? So these little numbers here are subscripts. Can't spell that, but they are subscripts. They are numbers written below the normal line of writing, okay? So there's another subscript here. It's a 3. Subscripts tell how many of each atom or ion there are, okay? So if you have a polyatomic ion that's in parentheses, like we do in this case, the subscript is going to get distributed to all the subscripts inside the parentheses. The one outside gets distributed to everything inside the parentheses. And by distributed, we mean we multiply them, right? So if we make a list of the different elements here, we have calcium, we have nitrogen, we have oxygen, okay? Right now, we have only one calcium because there's no subscript here. Okay, if we go to do nitrogen, here there's an implied 1, right? But we have to multiply by this 2 outside. So that's going to give us 2 nitrogens. And then oxygens, we're going to have 2 times 3 is 6. So that's how you would count that. Okay, now, pretend we didn't just do that. And there is like a big old 2 out here. Okay, so that 2 is not a subscript. That is called a coefficient, and that's what you use to balance your equations. There we go, efficient. And that 2 gets distributed to every element behind it, right? And you're going to multiply by its subscript. So in this case, if we put a coefficient of 2 there, we're not just going to have 1 calcium. We're going to have 1 times 2 is 2 calciums. We're not just going to have 2 nitrogens. We're going to have 2 times 2 is 4 nitrogens. And we're not just going to have 6 oxygens. We'll have double that, so that's 12. Okay, so make sure you can differentiate between subscripts and coefficients. As I pull this away, on your paper, write this down, 4, big 4, K2SO4. And then you're going to write down the elements and how many of each there are on your paper. Pause until you're finished doing that. So here we have our first unbalanced equation. The purpose of balancing equations is to get the number of atoms of each type of element on both sides of the equation to match. Remember, before your arrow, those are called your reactants. A bunch of people got this wrong on the quiz. After the arrow, those are called your products, right? Products is what is produced, what is made. Reactants are your starting substances. So in this case, we only have 2 elements. We have aluminum, Al, and we have Cl, okay? So I'm just going to make my little chart here and do my initial counting, okay? So we have 1 aluminum over here. We have 2 chlorines over here due to this subscript. Then on this side, we also have 1 aluminum, but we have 3 chlorines, all right? So obviously these lists don't match, and the purpose is to make them match. And the only thing you're allowed to do is in one of these blank spaces, you can add a whole number coefficient that applies to everything behind it, but it can't jump over plus signs or yield signs. Don't start with aluminum. They already match. We have to start with chlorine. We need more chlorines on the reactant side, okay? So there's already an implied 1 here. The next number would be a 2. But look, we only have chlorine here and here. It's not like in multiple places, multiple other places. So you can recognize putting a 2 here might not be that helpful because you're going to get 4 chlorines, but then there's no way to turn a 3 into a 4. But 2 and 3, least common multiple there, is 6, right? So you could potentially turn them both into a 6. So let's try it here. Let's put a 3 here. 3 times 2 gives us 6 chlorines, and it doesn't affect the aluminum on the reactant side. And then product side-wise, if we want 6 chlorines, we need to put a 2 here. 2 times 3 gives us 6 chlorines, but be careful, this 2 also affects the aluminum, so 2 times 1 is 2 aluminums. So we got good news down here, but our aluminums still don't match. However, we can easily turn a 1 into a 2 by putting a coefficient here. And our coefficients are 2, 3, 2 in that one. Now let's try the second equation. So there's something kind of special here. You have polyatomic ions in this one. So from your pink sheet, you can see that PO4 is like a little family, right? So we're going to keep that together in our list, and it's just going to make life a little easier when we go to balance. You actually have a second one in here, NO3. I'm just going to highlight that. All right, so instead of separating out the N's and the O's, we're just going to keep it together as NO3. Okay, so we have potassium, which is K. Then we are just going to list it as PO4. Okay, the next element is barium. And then we're going to list NO3, the nitrate ion, as one thing. Make life easier. You can do it a long way, but I promise this is going to be faster. All right, there's our chart. Let's start to count. We have 3 potassiums. Okay, be careful here. When I say how many PO4s do you have, the answer is 1. Okay, but a lot of people say 4 because they look right here. Ask yourself the question, not how many of these do I have, but how many PO4s do I have? The answer is only 1. If you had 4 of them, there would be parentheses here with a subscript outside. Okay, bariums is 1, and NO3s is 2. Okay, number outside the parentheses there. On the other side, I'll just go in order of my list. K is 1. PO4 right here is 2. BA right here is 3 of them. And then NO3, there's not a subscript outside the parentheses, so there's just 1 NO3. When you look at this list, we have a whole lot of nothing matching. Okay, so pick wherever you want to start. I think I'm going to start with my K's. Over here I only have 1. Here I have 3. If you multiply 1 times 3, you can get 3. So let me throw a coefficient of 3 here. That's going to affect my potassium, and I'm going to have 3 of them. It's also going to affect my NO3s. Now be careful, don't do 3 times 3 and get 9. It's 3 times 1 because there's only 1 NO3 to get 3 of those. All right, then what should I do next? Let's do my PO4s next. All right, here I have 1, and then here I have 2. So I am going to put a 2 in front of the K3PO4. That's going to change some things. 2 times 3 gives me 6 potassiums, and then 2 times, remember, there's just like a little 1 here, gives me 2 PO4s. Okay, good news, I got my PO4s to match. Bad news, even though I'd already kind of tried to do my potassiums, it ends up not working, right? Because now I have even more on my reactant side. That's okay. Get your eraser out. You never balance equations in pen. And erase this 3, okay? We want to fix that right now. We want to make that 3 into a 6. 6 times 1K gives us 6. And then 6 times 1 NO3 also gives us 6. So far we have the top 2 things matching and then nothing on the bottom matching yet. Let's go to barium. We have 1 here, 3 here. Let's throw a 3 out here. 3 times 1 is going to give us 3 bariums. 3 times 2 is going to give us 6 NO3s. Okay. Oh my goodness. Look, our lists match, right? We have 6 potassiums, 2 PO4s, 3 BAs, and 6 NO3s. Okay, and you can always go through and double check it. So the next slide is going to be work that you do. All right, so what I want you to do is copy these down carefully on your paper. Leave yourself room to put your coefficients. Do that work, and then that's what you're going to take a picture of and upload to the Google form. Okay? Good luck, and call me if you need anything.